So in this next part of the unit, we're going to talk about how we make sense of data. So far we've talked about research design, experimental, non-experimental methods. Now we're going to talk about, well, what do we do with the data once we've conducted the research and how do we make sense of it? So researchers use statistics for two major purposes. Descriptively, meaning to describe the data that's in front of them, the data that they've gathered from their research. And inferentially, to make an inference is to make a judgment, to judge whether or not the results that they obtained through the course of their research are due to chance or whether they're what we call statistically significant, meaning the results are outliers and they can then generalize the results to a larger population. So the goal today is to talk specifically about descriptive statistics. So this is how we organize data. One example would be to create what we call a frequency distribution. So if I'm using AP scores as my example, on the AP test you can earn a 1, a 2, a 3, a 4, or a 5. 5 is the best, by the way. I would write all the possible scores and then the frequency with which those scores occurred. So in this case, one person got a 5, 2 people got 4s, 4 people got 3s, 5 people got 2s, 2 people got 1s. I can then convert that frequency distribution into what I call a histogram. Now I want you to take note here about a histogram that the bars touch. The bars are kissing one another. That is not true of a bar graph. And I'm not the stat teacher. I know it has to do with the type of data being represented. Whether you create a histogram or a bar graph has to do with the type of data that you're representing. We don't need to get into that. All I need you to know is that if you're ever asked to make a histogram, hist, I guess sounds like kiss, the bars better be kissing. If you're ever asked to make a bar graph, you make sure that your bars are separated. So anyway, we see that we've simply taken the scores themselves, plotted them down here on the x-axis, and over here on the y-axis is the frequency. So again, just like we see over here, 2 people scored 1s, 1 person scored a 5, and we see the frequency of our results represented on a histogram. We can only describe data for the sample that we have. So in descriptive statistics, we're not making generalizations. We're just representing the data that we have. Measures of central tendency, meaning around where do most of our scores center. Mean, median, and mode, which I'm sure you've heard of before. Our mean is our average. Take all of the scores, add them up, divide by the number of scores. That's going to give you your mean. Your median, if I were to list all of my scores out in order, that's the middle score. The mode is the score that is most frequently occurring. Okay, so if we go back here, what would our mode be? Mode would be 2 because we have 5 people that scored a 2. We also want to measure how much our scores vary, how spread out they are. If I give a test and I notice that my scores are all over the place, that's really important for me to know. So 2 measures of variability are the range. You just take the top score minus the bottom score, and that gives you your range. And standard deviation. Standard deviation is much more widely used than range. Standard deviation is the average distance of each score from the mean. It takes all of the scores into account. So on average, how far is each score from the mean? We'll look at an example in a minute. This is our AP scores from 2018. So all I've done here is I've made a little frequency distribution that shows you our AP scores from 2018. Sorry I don't have more updated scores, but they were great last year and the year before as well. And then I've made a histogram. Okay, I've calculated my mean, which is a 3.91. My median was a 4. My mode was a score. You can see 31 people scored a 4. So that was my most frequently occurring score. And then you will never need to calculate standard deviation. But this is my standard deviation around here. That means each person's score was about 1 from the mean. On average, 1 from the mean. So this is what we call a normal distribution or a bell curve. In a normal distribution, about 68% of your scores will fall within one standard deviation of the mean. 95% of scores will fall within two standard deviations of the mean. Over here, down here, you see one standard deviation, two standard deviation, three standard deviations above the mean, 1, 2, 3 standard deviations below the mean. 99% of scores are going to fall within 3 standard deviations of the mean. And anybody down here who's outside of that range, we would consider to be what we call an outlier. You need to memorize this breakdown for a normal distribution. I want to use the example of IQ. The average IQ is set at 100. And standard deviation for IQ is 15. That means one standard deviation above the mean is a 115, and one standard deviation below the mean is an 85. Two standard deviations above the mean is a 130 IQ, which is typically considered gifted. Anybody with an IQ above that is kind of really off the charts, especially if you're getting down into here. Two standard deviations below the mean is a 70, which is in the ballpark of what is typically used to diagnose what we're going to learn as intellectual disability. So something like IQ, note I'm not saying intelligence, but IQ specifically, because IQ is a score. We could argue whether or not IQ is a good measure of intelligence. But anyway, this is how IQ scores are distributed. All right, in this type of a normal curve. If we were in person and I were to ask all of you to stand up, and I were to take data on your height, it would be likely that your height would fall into a normal curve. The more people I have in the room, the more likely it is that your heights are going to fall into a normal curve. There are lots of things that when you graph them out fall into a normal distribution. You're actually going to do this roll the dice activity on your own, or I guess you could get into groups and we could do it in groups as well. Maybe we'll do that.